Okay, here you have a hybrid of the two. You have a volume problem as well as a little bit of related rates. But here we go. So you have this cone shape, this funnel, okay? And they give you a few things. They tell you that the radius is that equation there. They're asking you for the average value. Okay, average value. So right away, I know it has to be the integral of r. Okay, in this case, it'll be with respect to h. From where to where, right? So from 0 to 10. So is that the average? Not quite. The average would have to include a fraction in the front, so that would be 1 over 10 minus 0, or 1 over 10. And there you go. Okay, find the average value, right? So the thing here is you gotta keep going because you gotta do your calculus part. So here I have 1/10 integral of 1 over 20, 3 plus h squared dh from 0 to 10. Okay, so a few things. I could pull out that 1 over 20 so that it's 1 over 200 on the outside, just so that it's not too overwhelming inside the integral. Okay, you integrate this here. The integral of 3 is just 3h. The integral of h squared is just h cubed over 3. And you're going to evaluate from 0 to 10. Let's keep going. We always plug in our upper first. So here we go. 3 times 10 plus 10 cubed over 3. I'll group that whole thing. Minus 3 times 0 plus 0 cubed over 3. Equals equal. You can leave it there. But it does come out to 109 over 60. But who the heck cares? Okay. Finding the volume. Okay, so you're trying to find the volume of this function here. So what you want to do is, if you notice, you're revolving this around. Kind of hard to picture, but you're spinning it. If you want to turn this thing sideways, you'll notice that this curve here is spinning around, creating this funnel. Okay, so what you have to do is you have to use the disk method. Okay, so here I'll refer to the scoring guidelines. Notice how we have a disk. So you start with the pi. Okay, and then it's going to be your function squared. Okay, so the setup is probably the toughest part. Okay, once you set it up, everything else is just analytical. So here we go. We have, I'll do it over here, pi integral from 0 to 10 of 1 over 20, 3 plus h squared squared. Okay, so first off, the 1 over 20 is being squared, which is 1 over 400. So I could actually take out the 1 over 400 along with my pi on the outside. Okay, all I have left on the inside is 3 plus h squared squared. Now this right here, you can expand. That's just 3 plus h squared times 3 plus h squared, which is 9 plus 6h squared plus h to the 4th. Okay, so again, we didn't integrate just yet. Okay, so once you integrate, you should get 9h plus 6h cubed over 3, or 2h cubed equivalently, and h to the 5th over 5. Pretty much the moment you guys plug in your upper minus your lower, leave it there. Don't go as far as they did, because that's just a waste of time. Okay? Here's part C. So the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height with respect to time? Whew. Okay, here we go. So just approaching this from your perspective, what I would do is I would read the question. What are they asking for? What is the rate of change of the height of the liquid with respect to time? Okay, what that means, they're looking for height, but they're looking for the rate. So that'll be dh with respect to time dt. This is what you want. Okay? So they give you this equation right here. All you have to do is get the differential. So first thing that I'm going to do is I'm going to distribute that 1 over 20 just to make things a little bit easier, in my opinion. Okay? So when I take the differential of this, the differential of r is just dr. The differential of 3 over 20 is just 0 because it's a constant. And the differential of 1 over 20h squared is just 1 over 20 times 2h, but with respect to h. And then I divide my differentials by dt. Notice how I have dh dt right there. Okay? So they tell me that h is 3 and that dr dt is decreasing. If something is decreasing, then its derivative is negative 1/5. This becomes just solving for a variable here, okay? But I'll keep going. Negative 1/5 is equal to 6 over 20 dh dt. I'm going to multiply both sides by 20 over 6. And then dh dt will be that answer right there. Equals equal. You don't have to keep going, okay? They don't ask for units either, so just keep that in mind.